So now we are Unit 3, the link between primary mathematical concepts and higher mathematical concepts. We have already seen Unit 1, in which I think we have explained very well the beauty and the simplicity of a certain idea, that every single thing is implicit measurement. When we are seeing something, we are seeing how dark, how light, how clear it is. When we enter a room, we see how dim or see. Every time our senses are operating in terms of implicit measurements. Then we understood that the implicit measurements have been made explicit. We got the ladder, basic number 1, then 1, 2, 3, 4, 5, 6, 7, 8, 9, then the place value system, small numbers, all operations, plus minus into division. Big numbers, all operations, plus minus into division. Fraction, we understood fractions very well. You can go back to the video if you want, if you have not gone into that. And decimals are also kind of fraction, we explained that also, powers, and we gave the concept of how we must teach, and we kept repeating. I think I must have repeated 50 times till now. Connected to reality, connected to that. Let him see the reality. It doesn't matter if he doesn't learn mathematics, because mathematics is there in reality anyway. Link between primary mathematical concepts and higher mathematical concepts. That would complete our course on school level mathematics. Now when we come to the higher mathematical concepts, that comes from 6th class, let's say, to the 10th class or a little more, we encounter a variety of topics. Let's take one topic and see how the primary mathematical concepts pave the way for a clarity about the higher concepts. I repeat, let's take one topic and see how the primary mathematical concepts are paving the way for a clarity about the higher concepts. Let's take the first concept of percentages or discounts or compound interest. For example, in percentage, when you say you have a person who got 60%, it is clear that a person didn't get exactly, literally 60 out of 100. He might have got something else, like 60 out of 600 or 1000 marks total. But you say his percent is 60. He might have got something out of something. Let's say he got 360 marks out of 3600. So percent or per 100 is a concept clearly connected to fractions, right? So if you know fractions, you've got the concept of percent. Percent is, obviously we find it easy to see how much, if it was 100, how much he got. Percent. So if he got 600, like he got 360 out of 600, out of 100 he got 60%, right? But 360 out of 600 is not clear. 60% is very clear. Percent is simply out of 100 how much. This is obviously a concept of fractions. A person in the primary mathematical stage, having learned fractions perfectly, like we explained in the previous video, as illustrated in the last chapter or video, would easily understand the concept of percentages, discounts, and interest. Easily. There will be nothing in it. In fact, I'm sure 50% of people who are listening to this video would find nothing in it. Compound, this is interest on compounding, simple interest, compound interest, even workplace. This is because once he gets the concept of fractions connected to real life, the concept of percentage or discount would be just merely an additional application than something entirely new. Notice that in most schools, this concept is not fully clear. They are not fully clear in the primary section. So when they come to the higher level, they get all confused. Like fraction is different, percentage is different, interest is different. It is only fraction. So when they come to the higher level, it becomes mechanical. Like you say, 50% means 50 by 100. Why is 50% 50 by 100? It is 50 by 100 percent. But no, they get confused. 36%, they say, teacher says 36% is 36 by 100. Mechanical. Don't do it like that. We don't know why we are saying 50% is 50 by 100 or 50 as a fraction. Because what's the concept of percent? What's the meaning of percent? Percent means out of 100 how much? So 50 out of 100 is obviously 50 by 100 fraction. We don't know why, but actually the concept is very simple. I again repeat, the litmus test of any concept, not just in mathematics, but in any subject. If you do not know it like elementary, you have not got it. You should be honest that you didn't get it. But actually the concept is very simple, and this detachment from real life is needless. This concept is seemingly so difficult for many people simply because and merely because in the primary level they did not get the concept of fractions. They did not connect it to reality, real life. They did not do it through games as we saw that we should do in the last chapter. So if you don't do that, this problem will never get solved, and it has not got solved in education, let me say bluntly. Everywhere I go, same problems. They go to top schools, international schools, schools which have been voted as the best school in the world. And look at the students, I look at the students, they're not clear on fractions. They can't add properly. So many. And even if they do, even if the smart students who get marks, I ask them the concept. If I slightly twist it, they lose. If you don't get the concept, you're only mechanically doing to get marks. So even the people, that's the biggest joke, who are getting marks are not able to finally do anything in real life. They can't create. I have seen people who are weak in so-called weak in mathematics, but good in thinking, who learned because of some reason very high level mathematics for some purpose. In fact, Elon Musk would be a good example how he learns on the job. So if you don't do this, this problem will never get solved. The only way to solve the problem in higher mathematical concepts is the same. There's only one way to solve the problem of mathematics on the higher level, and that is to make the foundation in the primary level extremely strong. And after that, I repeat, it is only arithmetic. By strong here, we mean connected to real, again I'm saying the same thing, in real world through activities and games. I get a lot of complaints saying that I say the same thing. I say the same thing because there's nothing else for me to say. So that is the only way. Now suppose we take geometry. Even geometry is mainly about numbers. Manipulation of numbers with additional concepts of what is a cube, what is a cone, what is a cylinder, what is a circle. Pi r square, you have to understand what is pi. But finally it is arithmetic only. So you can say higher mathematical concepts is some applied concept in real life with basis numbers only, arithmetic only. When you take algebra, the concept of the x and y will be very clear if you are clear about numbers as such. Suppose you say 2 plus x is equal to 5. You have 2, you add a number and you get 5. Even a villager who doesn't know higher mathematics or algebra will tell you add 3 only. What is so great about it? I told you, mathematics, a great renowned philosopher said, the easiest, most elementary subject in the world is mathematics. Because it's just numbers. He said there is no subject in mathematics. It is only 1 to 9. So 2 plus x, 2 plus 3 is equal to 5, obviously. A good student will clearly understand x as simply an unknown number. Student will look at x not with the phobia, but he will simply look at that number which when added to 2 would give 5, and he will be confident that it should be 3. And once he gets the concept, then he can understand x square also, because he knows 2 square, 3 square. So he says, okay, some number into that same number. 2 square means 2 into 2. So x square means x into x. What is x to the power of y? X multiplied y times. Why do we get so frightened of x and y? It is simply a number which has some value, but I don't know what that value is. But he will simply look at that number which when added to 2 would give 5, and he'll be confident that it should be 3. And there's all rules in algebra again. If he gets the basic concepts and if he gets the concept of x, then the rules of algebra would seem simple and very easy from number concepts only, with x simply seen as an unknown number. So as you can notice, once the primary basic mathematical concepts are crystal clear and connected to real life, and I would add very comfortable he is with it, he can imagine it, it's there in his imagery in his mind, the higher level concepts actually become elementary, very simple. And also the student has a power to understand the concepts in a powerful way, really. Something happens, I don't know how to explain it. I'm sure people who are scientists will understand my point obviously very easily. When he gets the higher concepts, it's like he becomes like a mini Ramanujan, he can play with it. These are the people who become very good scientists, inventors, engineers, and even when they go into humanities, that mathematical thinking doesn't go. They're very clear. If you notice if a person is very good at mathematics, his thinking will be very logical in other areas. It's very well accepted anywhere. Strangely, the easiest subject in the world makes you highly intelligent. Maybe that's why there's so much mystery, so much mystical element in mathematics. Something is there. He becomes actually powerful when he goes on the higher level concepts like in trigonometry. What is trigonometry? Only a ratio. Angles in a right angle triangle. We know that. Ratios are simply fractions. And again, a student who is comfortable with fractions would grasp trigonometry too, which connects angles with lengths or ratios. I have seen the textbooks of NCERT and even our own, our state, Andhra Pradesh state books. They have explained the concept so well. Even if you follow the textbooks with now this insight, I hope you are motivated now to read the textbooks of mathematics properly. In calculus, they talk about rate of change of one variable or quantity with respect to another every moment, or continuous change. See, continuous change, continuously. Our body is falling every moment, but we can't catch every moment. That's where calculus comes in. I will leave it here because this is not a book on mathematics, but trust me, just take my word for it. Put numbers in the calculus or read very good books in it. Get the concept of dy by dx and integration and limits and all. In calculus, they talk about rate of change of one variable or quantity with respect to another, how one thing changes with respect to another every moment. Here too, it is like algebra. And if we can arithmetize algebra, we can arithmetize the concepts of differentiation, limits and integration also, and that would also be very clear. Same thing with other topics. What are other topics? Statistics, probability, series, permutations, coordinate geometry. Coordinate geometry is very beautiful. Y is equal to x square is parabola. Really, check it. Put a graph. That's how they do it in good textbooks. Y is equal to mx plus c, or rather, y is equal to, let's say, 3x plus 4 is a straight line. You can check it. Y is equal to 3x is a straight line. It's a linear relationship, they say. I hope you're getting the point that it is all arithmetic. I think even with these videos, I'm sure 6 out of 10 people who are listening to these videos will become masters at mathematics. That's how I do remedial training. After 2 weeks, no student comes back to me. He starts learning on his own. Same thing happens with other topics like statistics, probability, series, permutations, coordinate geometry. Now do you see the tragedy of the teaching of mathematics? I hope you see, I hope you are concerned now. How can you be concerned about something when you don't even know what you have to be concerned about? This is what you have to be concerned about. That we don't know, that we don't know. We don't know that we don't know. You should be very humble when it comes to subjects. Even at 57 I'm very humble. I know very little because I know what I know. The people who know a little bit very well know there's a whole ocean of knowledge which they can never know. But that little, I like to say, is in that little is the ocean. It's not that you have to enter the ocean is in that little. This is the ocean. In all these you have simply quantitative relationships between two or more measurable quantities. Y is equal to x square is a quantitative relationship. Thus, we can go to physics, we can go into economics, we can go to any field, and wherever there is something measurable, two quantities, they have a relationship, there comes in mathematics. Now do you see why we require mathematics to go to the moon? We can't go by physics. We have to go to the moon with mathematics precisely. Without calculation. The whole Google runs on mathematics. It's a coded mathematics. Invented by Sergey Brin and Larry Page. That is why they are genius mathematicians who became genius businessmen. Even Aran Murthy, he became a genius IT master he was. So he became a genius businessman. He got a vision. I can do this, which people are not doing. I'll give quality. That's how, with subject knowledge, you become great. In all these, you have simply quantitative relationships between two or more measurable quantities and a clear concept in a certain situation. As we go, even on the highest level, the relationships and patterns become more. So even in engineering, you have differential equations, 4-year series, something called vector calculus, which Masar is doing right now. They are also not difficult. But again, arithmetize only. Get the concept of mathematics. Mathematics is not a game. Not at all. All the people who finally become scientists and inventors, great technologists, are those people who have very solid foundational concepts on the primary level because they can think mathematically. They are comfortable in mathematical concepts, even on the highest level, which in their mind are rooted in the basic concepts. They are learned conceptually like a ladder. They are not detached from real life. That is why they succeed. But what's happening in schools? That is our area of concern. That is why I'm making these videos. If you notice, in schools, all these higher level concepts are detached from reality. They're again played as a game, whether it is trigonometry or coordinate geometry or geometry. Go to any school. The world over. Sometimes it baffles me. Like sometimes I go into almost like, I don't know, my head breaks, like, how comes man is so stupid? Isn't there one person in the world who can make it better? Sometimes I think it's political almost, socially idiotic. Why are we becoming like that? I think that is going to be the next wave, I feel. Surely, if not me, this is a very humble attempt. Surely there is a scope for a genius in education to come and change this whole educational field. We know very well the students get marks, but they are not able to use this mathematics they are learning because they don't have any idea why they are learning, what they are learning. And there's a common experience that so many people ask, why am I learning this? Like for example, they keep on doing these derivations and trigonometry. When you go into the subject of mathematics, you have this derivation, like sin square theta is cos square theta is equal to 1. They don't know why they're doing it. LHS is equal to RHS. Now you know how to do it. Why they're doing it. These equations are used somewhere. Remember that. Even while doing it, do it abstractly. Have a selfish interest in your life. Trust the great people who have given you the syllabus. Do it well, but do it conceptually. One day you will start applying it. Like for example, they keep on doing this derivations in trigonometry, but they don't know why they're doing it. They don't understand that trigonometry is relating one thing with another. For example, in physics, you have a concept like sin I by sin R is equal to refractive index. You know, when a ray moves and enters a glass, it bends. At different angles, it bends at different angles, but there's a relationship. Listen carefully, there's a relationship between the angle of incidence and the angle of refraction or bending. When you divide it as sin I by sin R, it is always a constant. Now, see how beautifully it has been applied. Trigonometry has been applied here. So, this is obviously sin I is a number, sin R is a number, but in this way they are related. It is not I by R is equal to constant. It's sin I by sin R. I is an angle. Sin I by sin R is equal to refractive index. When you put the numbers, even you might feel I'm telling a great concept, there's nothing in it. It is just a simple ratio. Is equal to refractive index. So when medium A, specific medium air, it goes to glass, its refractive index is always one number only. That makes sense, isn't it? Where you are relating using the trigonometry for a certain real life application. Trust me, the whole world is running on mathematics. But with some concepts derived from that particular subject. There will be mathematics in economics, there will be mathematics in physics, in chemistry also. In the same way, you are using the sine wave in physics. Sine wave. Where you are showing the relationship again of one variable with another. Now, these are concepts to show relationships between things. So, once basic concepts of relationship of numbers and fractions are absolutely reality oriented, once a student can observe patterns and grasp higher level concepts as connected to reality, such a student feels mathematics to be very simple. And also he becomes adept in using, very skilled in using mathematics in real life. Sometimes even innovatively, creatively. That's what Larry Page and Sergey Brin did. They got a proper searching mathematical algorithm by which the number of, suppose you click mathematics in primary level, the in Google. So what happens? The websites which are coming in the highest level, the immediate websites, top websites, they come in order, isn't it? All they did was to find out a way by which this algorithm measures all the websites, counts the number of clicks they've had, views they've had, and put highest first, second highest next, and so on. Page 9 system. I'm just giving us, but it's not as simple as this. It took a huge amount of genius. Mathematics is numbers and manipulation of numbers. It is simple as a concept, but it has got power, and in the higher levels it can become very complex. But the complexity is based on some simple rules. Again, we see the power of grasping of all mathematical concepts conceptually, and the uselessness of detaching mathematics from real life. And we'll go to the next video, the relationship of mathematics and other fields and subjects. The next topic, maths is a very powerful subject, and since it deals with measurements, pattern recognition, logical connections, directly or indirectly, it is related to almost every subject you can think of. Relationship of mathematics to physics. It's a very common fact that in physics you will find lots of equations. You will find, for example, trigonometry and calculus used directly, because physics is about the relationship of one variable with another. Let's take the equation of the universal law of gravitation to see how mathematics becomes very important in physics. The law is F is equal to G m1 m2 by r square. This is actually a proportionality relationship. F is directly proportional to M1, F is directly proportional to M2, F is inversely proportional to the square of R, and there is a proportionality constant. This is concept in primary mathematics. Proportionality. If you double M1, F will be doubled. If you double M2, F will be doubled. If you doubled R, F will be reduced 4 times. If you triple R, F will be reduced 9 times. R square, no. That's a concept. There's a concept in 6th standard mathematics called proportionality. You have a direct proportionality or you have an inverse proportionality concept. I'm just giving this example to again illustrate, if a student doesn't understand these concepts, he will not understand the physics equation. Again, it will become mechanical. It would not connect to reality. But if a student understands these concepts, then he will be able to see the physics concepts and the actual reality there. He will see that one mass is attracting another mass. If you double the distance, then 4 times the force reduces. If you triple the distance, 9 times of the force reduces, etc. That reality of the equation will be seen by him. One easy way is put numbers. Put M1 some number, M2 some number, R some number. Put more numbers. Keep one constant and keep on changing the other. Play with it. Play with every equation by putting numbers. Simple. And see the pattern yourself. But largely, this is not the case. And most students see this equation like an abstract equation with a bit of fear in them, or with no feeling in them, with obviously no connect to real life. That's the reason why they have problems in physics when they come to physics. That's why physics is considered a difficult subject. F is equal to G1M2 by R square is a mechanical equation manipulated mechanically. They make physics maths actually. They make physics mechanical maths. If the maths were known, if that proportionality concepts were known and properly taught, that physics would have become very clear. Because mathematics, we repeat, is a connection to reality. Again, entering the 100th time of relationship of one variable to another. We are able to connect the whole of physics to reality only when we connect the equations properly to reality. Maths and physics are deeply, inherently interconnected. In fact, many of the maths concepts that came, this is very interesting, were invented by physicists. Newton invented calculus, down history to manage quantitative relationships. The relationship of maths with economics, politics, management, etc. is obvious. There's a lot of statistics, there's a lot of percentages, graphs. Obviously, there's a lot of mathematics involved with economics and social sciences, because when you talk about GDP, for example, there are very different ways you talk about GDP. When I look at this analysis of economics, just 2 days back I was looking at a video of in print and he showed me like 10 graphs about how the freebies given to the government are affecting the economy. So many different ways he was explaining the graph. So much of concept is there, so much of meaning is there in the graph. Nowadays there's a lot of propaganda done by manipulating numbers, but if you're good at understanding the concept of a number, concept of percentages, how to be analytical through numbers, I think a good way of putting it. You have to be analytical through numbers. You will be in a better position to analyze data, huge data, whether it is statistical or percentages or other concepts in economics. Even calculus is nowadays used in economics. It's called mathematical economics because things are changing, and wherever there is a change, continuously, wherever there is data, wherever there is a relationship of one variable with another, math comes in inevitably, as we said earlier. Math, I would love to repeat, deep feeling, which I can't actually put it in words, is an inherent, natural and intrinsic part of reality, almost the way we kind of deal with reality. Again, maths is obviously very, very deeply connected with engineering. Whether it's computer science or architecture or civil engineering or any other engineering, you have absolutely deep, advanced, applied mathematical concepts to handle complex situations. For example, Google is nothing, I've already given the example, it's nothing but a way by which hundreds of variables are manipulated through very complex mathematics. But everything is broken down, you understand? But if you notice that at every step it is measurements, it is relationships, it's patterns, it's logical connections, quantitatively connected to each other. Quantitatively connected to each other, that's it. So obviously in technology also maths comes in. Such connection of mathematics to various fields are innumerable. Also mathematics being so precise enhances senses directly or indirectly, comes in arts. It really comes in arts, I know that. Painters are. Do you think that painters are very artistic, they're just freely? No, they're not freely drawing. They're observing reality. The way an artist looks at a flower, you don't. I came to know because in last 2 years I've been a little bit into appreciating paint. I'm seeing how sharply they see. Sharp seeing is mathematics. At least for me, music is listening. One of my friends said, you have a good voice. You can learn. You're a smart guy. Don't learn music. Listen to sounds as keenly as you can. One day you'll learn. I'm doing that. Really, I listen. When I listen to a song, I listen very keenly. I don't want to miss even a slight change of note. It's mathematics. Direct to indirect comes in arts like painting, music, dance. Dance also. The way you move with grace and perfection. See, architecture. Also, a student who masters mathematics the way we have explained in this book becomes very sharp in logical thinking too, and very precise. So that is a connection of mathematics with real life, other subjects. It's very well known. People are good at mathematics, are good at other life subjects. But there could be a person who say, no, I was very bad at mathematics, but I'm very good at logical thinking. You are bad at mathematics because you are taught mathematics badly. Your mind is very mathematical. That's the point there. Mathematics is an expression of your intelligence to discern, to be sensitive, to be sharp. So, what is the power of mathematics? In conclusion, we can say that mathematics is that science or art by which we have concepts which handles data, which handles relationships, which handles patterns, so that we can gain power in any subject by using quantitative measurements, relationships, and patterns to handle, to reduce large data, to come to certain creativity with respect to creating large scale things like a bridge, skyscraper, going to the moon. Oh my god, so many things. So, mathematics is a literal power. It expands your mind, it enables you to handle large amounts of data. That is when you go to a city and you see the pictures of the city, remember that whole thing was created with the power of the mind, of concepts. We close the whole book or series here with one great quotation: knowledge is power. But we would like to add that knowledge is coded through mathematics. So it is mathematics which makes knowledge a great power. Thank you. We enjoyed sharing all this with you all, and there are more playlists here on mathematics, on physics in nrkacademy.com, which is our website, or NRK Academy YouTube. You can go to our whole series where we have taught the subject of mathematics also. So I hope you enjoyed this series of 3 long videos, and I'm sure something must have happened to you, because our purpose is not to spoon feed you, but to ignite and to open your eyes. And once your eyes are open, can you close it? Thank you.